Every single business out there faces these incredibly complex puzzles, right? They've got millions of variables where just one tiny change can have these huge knock-on effects on the bottom line. So today we're going to see how a company can use data not just to find an answer, but to find the single perfect answer and turn all that complexity into clear, profitable action. And to see what that looks like, well, we've got to start with the right question. So how do you do it? How do you solve a million-dollar puzzle that has literally millions of possible answers? I mean, imagine you have to make a choice that could save or cost your company a fortune. There are just countless options, and your job is to find the single best one. It sounds impossible, doesn't it? It's like trying to find a needle in an infinitely big haystack. Well, it turns out there's a map to that needle. And to see how that map works, let's meet our case study for today, a company called Green Grow Organic Foods. They have a classic real-world business problem. They've got produce sitting in two different distribution centers, one in Portland and one in Chicago. And they need to get all that produce to three huge supermarket chains, Whole Foods, Fresh Market, and Nature's Basket. The goal? Super simple. Do it for the absolute lowest possible cost. And that, right there, sets the stage for what we're going to call the Green Grow shipping puzzle. Now, sending some boxes from point A to point B might sound easy, but once you start factoring in all the real-world costs and limits and needs, you end up with a seriously tangled web of variables. And here is that tangled web in all its glory. This spreadsheet, this shows you the raw complexity of what they're dealing with. See, every single route, from Portland to Whole Foods or Chicago to Nature's Basket, has a different price tag. And on top of that, the Portland Center can only ship out 180 crates max. Chicago is capped at 220. And to make it even trickier, each supermarket has a minimum number of crates they have to receive. Yeah, trying to solve this one with just a hunch, that's a recipe for disaster. So how in the world do you untangle a mess like this? Well, you definitely don't rely on guesswork. You use a very precise tool to find not just a good plan, but the mathematically perfect one. Okay, so the tool for the job is called linear programming. Now, don't let the name scare you off. Just think of it like a super intelligent assistant. You give it one main goal. In this case, it's minimize our total shipping costs. Then you give it the rules of the game, supply limits, customer demand, all that stuff. And then it just churns through every single possible combination to find the one plan that meets your goal perfectly. And so after the model crunches all the numbers and sifts through every possible scenario for Green Grow, it spits out this number, $3,380. And let me be clear, this is not just a good guess. This is the absolute rock-bottom, lowest possible cost to ship all of their produce. Any other combination would cost them more money. This is the optimal solution. So how do we actually get to that number? Well, the model gives us this beautiful, precise shipping plan. It says, Portland sends 70 crates to Fresh Market and 110 to Nature's Basket. Chicago, you handle the rest. But just as important is what the model tells us not to do. See those zeros? It's telling us, hey, avoid these routes completely. They are just too expensive to ever be part of your perfect plan. Okay, so problem solved, right? We've got our magic number, we've got our perfect plan, we can all go home. But hang on a second, the real world isn't static, is it? What happens if fuel prices shoot up and the cost to ship from Portland suddenly changes? Or what if Fresh Market has a massive sale and suddenly needs 20 more crates? Does our perfect plan just completely fall apart? This is where the real magic happens. Yeah, this is where we move from just finding a single answer to building a strategy that can actually survive the chaos of the real world. And we do that by asking, what if, with a technique called sensitivity analysis. You can think of it as a way to stress test our perfect plan to see how it holds up. Okay, so this right here is the sensitivity report, and I know, it looks like a wall of numbers, but trust me, it tells a fascinating story. We're going to decode it by focusing on just two key concepts that every single manager needs to understand: reduced cost and shadow price. All right, first up, reduced cost. Now, this number is really important, but it only applies to the shipping routes that we are not currently using. Those ones with the zeros. Think of it like a sale price target. It tells you exactly how much cheaper an unused route has to get before it's actually a good deal and worth adding to our plan. Let's look at a real example. Remember how the model told us don't ship from Portland to Whole Foods? Okay, so the report shows its current cost is $10. Its reduced cost is $4. So what does that actually mean for a manager? It means this. unless the shipping price for that specific route drops by at least $4, all the way down to $6 or less, the model's advice is crystal clear. Don't even think about using it. So, to recap, for a route that's out of the plan, you look at its reduced cost. But what about a route that's already in the plan, like Portland to Fresh Market? Well, its reduced cost is zero. Instead, it has something called an allowable range. The current cost for that route is $8. The report tells us our plan is totally solid as long as that price stays somewhere between $7 and $9. It's like a sensitivity window. If the price moves just $1 outside that range, our whole plan breaks and we got to run the numbers all over again. All right, so we've dug into the costs of all our shipping routes. But what about the limits of our own operations? The sensitivity report also gives us these incredible insights into our own supply and demand. This is where we find those hidden bottlenecks that are just bleeding money and also the hidden opportunities for growth. And to do that, we need our second key concept, shadow price. This is an incredibly powerful idea for any leader. Basically, the shadow price tells you exactly how much your total cost will change if you can get your hands on just one more unit of a resource that you've totally maxed out. It puts a precise dollar value on breaking through a bottleneck. So let's compare GreenGrow's two warehouses. The Portland Center, that's what we call a binding constraint, which is just a fancy way of saying it's a bottleneck. It shipped out every single one of its 180 available crates. It has zero slack or leftover capacity. Now compare that to Chicago, which is non-binding. It shipped 200 crates, but it had 220 available, so it has 20 crates of slack. There's no bottleneck there at all. So right now, getting more capacity in Chicago, it's pretty much worthless. So what is the shadow price for our big bottleneck, the Portland Distribution Center? It's this number right here, -$1. Now, that little negative sign is the whole key. Remember, our main goal is to minimize costs, so a negative number is exactly what we want to see. This shadow price is telling GreenGrow's management something incredibly powerful. It's saying, hey, your Portland supply is your single biggest bottleneck. And for every single extra crate you can get your hands on and ship out of Portland, your company's total shipping costs will go down by $1. Now that is a massive strategic insight. So what is the point of all these numbers? They aren't just for some report that sits on a desk. They are a direct roadmap for making smarter, faster, more profitable business decisions. Let's translate all this data into a real-world strategic action plan. I mean, just look at how powerful this is. First, the analysis flat out tells us that Nature's Basket is our most expensive customer to supply. So what do? We go investigate. Why? Can we renegotiate our contract? Second, we know for a fact that the Portland supply is a major bottleneck worth $1 per crate. The action there is obvious. Find a way to increase capacity in Portland because every extra crate directly lowers our total costs. And third, we learned that the shipping cost from Portland to Fresh Market is super sensitive. It only has a $1 wiggle room. So what's the move? You get on the phone to that shipper and lock in that $8 rate because any tiny fluctuation will force you to change your entire logistics plan. So at the end of the day, what we've really learned here is that optimization isn't about finding one single magic number like $3,380. It's about understanding the entire system, the sensitivities, the bottlenecks, all the hidden relationships between your choices. It gives you the power to not only make the perfect decision for today, but to see the future and adapt to the challenges of tomorrow. So the final question is, what hidden forces are shaping your decisions?